Thomas Edison. Whenever one hears his name, immediately they think of the light bulb. Like this one here. It's a replica of Edison's most famous invention. Indeed, this is one of the most profound inventions that Edison, or anyone for that matter, has ever made. Well, probably with the exception of the wheel and fire. This room that I'm in has several light bulbs illuminating it. And as further proof of the impact that this invention has had on the world, here is a montage image of the Earth at night. There's easily over 1 trillion light bulbs in this image. So, I have a book here about Edison, and it has a photo on its cover I'd like you to show to you. This photo here, I would argue, is the most profound photo ever to have been taken. No, it's not because it shows Edison with a light bulb in his hand. There's plenty of photos of that. It's the particular light bulb that he is holding, and the other two next to him. Look at them closely. There's something strange about these light bulbs, and it is that strangeness that makes this photo so profound. I'll come back to this photo in a moment. The light bulb was only one of over 1,600 inventions or patents that Edison had filed under his name. Edison had invented numerous other devices, such as the dynamo, power distribution grids, rechargeable batteries, movie cameras and movie picture projectors, and his most favorite invention, the phonograph. Yes, Edison was truly prolific with his designs and inventions. People called him the Wizard of Menlo Park. Menlo Park was the location of his first laboratory before he moved to his factory in East Orange, New Jersey. But he had one curious and little-known invention that put his name into the annals of, no, not inventors, but of scientific literature. An invention that could have won him a Nobel Prize in physics if he had simply written it down as a scientific paper instead of just filing a patent. That invention, discovery, became known as the Edison effect. So, what is the Edison effect? Well, after Edison had invented the light bulb, and while he was improving on its design before mass production and sale, he noticed that the filaments in the bulbs, after being left on for a while, would start to get black on one end. Eventually, the filament would break after about 40 hours of use, meaning that the bulb would have to be discarded and replaced with a new bulb. He also observed that the filament would blacken and then break on the end of the filament that was attached to the positive lead that was powering the bulb. Edison was using DC, or direct current, as his power source. So, what was going on inside of Edison's bulbs? Now, there was a theory known at the time called thermionic emission. Since the concept of an electron had not yet been defined when Edison was having these problems with his bulbs, electric charge was simply thought of as some kind of invisible force, a flux, such as magnetism or gravity, but which had a property kind of like water, since it could flow through a conductor and thus create a current. It was also known that this flow showed a form of pressure, which was referred to as voltage. In addition, it was recognized that electricity had a polarity to it, meaning that there was both a positive charge and a negative charge to electricity. But thermionic emission was a curious property that had no solid theory to explain what it actually was. Scientists had observed thermionic emission before Edison by heating up metal orbs in the lab, giving the orbs a negative charge, and then observing that the charge slowly dissipated, but couldn't explain exactly what was happening. Where was the charge going? Edison seized on the results of these earlier experiments and wondered if this electric charge was somehow flowing from his filaments and into the glass of his bulbs. But that made no sense because glass was an insulator and couldn't conduct electricity. Consequently, in 1880, he came up with the idea to insert an electrode, a piece of wire, into the bulb close to the filament, but not touching it, then applying an electric current to the filament. Here's that photo again of him holding that experimental bulb in his hand. You can clearly see this electrode inside the tube affixed to the bulb, and the nub where the electrode protrudes outside of the bulb. The second bulb, immediately to Edison's right, has two electrodes inside of it, and the third bulb appears to have something going on inside of it, but it's not clear what it's for. As an aside, note, this was Edison's style of invention, to make all sorts of different configurations of the things that he was experimenting on, trying this and then trying that, hoping that one of them would bear fruit. But back to his strange bulbs. With these experimental bulbs, Edison would attach a galvanometer between the end of the electrode that was outside the bulb and the positive end of his electrical source. He noticed that as the filament heated up, the galvanometer registered a current flow. So, negative electricity has somehow flown from the filament through the vacuum inside the bulb and to the electrode, and then out into the galvanometer. He also noticed that this flow increased if he increased the voltage on the filament. Boom! Electricity flows through a vacuum. Electricity must be something physical, possibly a particle of some sort. Edison then tried connecting the galvanometer to the negative end of the power supply, but found that the current flow stopped completely. Curious indeed. Negative electricity could flow through a vacuum, but positive electricity can't? Was Edison onto something here? Edison then tried to see if he could somehow stop this flow of negative electricity inside the bulb. He built another bulb, perhaps that's what that third bulb is all about, that not only had an electrode in it, but also a foil positioned inside between the electrode and the filament, but not touching either element. The foil had its own connection leading outside of the bulb. He turned the bulb on and allowed the filament time to heat up. Now, what he found was, if the foil was not connected to anything, he would still get a current on the galvanometer. If he connected the foil to the positive end of the power supply, he would still get a current flow. However, if he connected the foil to the negative end of the power supply, then the current flow would stop completely. He could then turn this current flow on and then off by simply connecting and disconnecting the foil to the negative supply. Outstanding. Conclusion: electricity was something physical, not a false, as what magnetism and gravity are. It also appeared to form some physical part of matter, since the filament, when heated, blackens and then breaks when the negative electricity leaves it. This current flow has negative charge to it and can be blocked with another negative charge. In other words, opposite charges attract and same charges repel. These physical negative particles can be separated away from matter, but whatever creates the positive charge can't be separated away from matter. It could be speculated that this discovery inspired a physicist by the name of Joseph John Thomas, who, in 1897, finally observed and identified the electron. Although there had been some speculation about a subatomic particle with negative charge for quite some time, and that a heated metallic object appeared to radiate this negative charge somehow. It wasn't until Edison performed these experiments and was able to quantifiably demonstrate the effect and the compelling evidence that there was indeed a subatomic particle with negative charge. Edison probably had an unfair advantage over the scientists who preceded him for making this discovery because he was performing the experiment inside evacuated bulbs, so there was no air involved to interfere with the electric flow. Plus, he had the means at his disposal to quickly fabricate these bulbs in his laboratory and try out different configurations, as you saw in that photo of him. All of this was astonishing and only added to his moniker of being the Wizard of Menlo Park. But Edison didn't see any real practical use for this strange phenomenon, so he simply filed a patent on it and then moved on to other things. But what was the importance of this discovery? What was it that Edison didn't realize or understand about his experiment that could have elevated his notoriety to the level of Einstein? Why is this photograph the most profound photograph ever taken? Join me in the next video about an engineer by the name of John Ambrose Fleming, a gentleman who consulted with Edison and later used Edison's discovery to create the field of electronics, and thus make Edison the father of all things electronic. See you then.